Hi everyone, welcome back to our channel. Today we are going to discuss about different types of interconnections of an two-port network. So what are the different types of interconnections? So coming to these different types of interconnecting two-port network are three types. First one is series connection or series interconnection. Second one is cascade, which is also a part of series interconnection. Series connection. And third one is parallel connection. So here in this series interconnection, we are going to perform the sum of Z parameters. In the case of cascade connection, we are going to perform product of ABCD parameter. In the case of parallel connection, we are going to parallel means sum of Y parameters. This is very important in competitive exam. Series interconnection of two-port is done with the sum of Z parameter. Cascade connection of two-port network is possible with the help of ABCD parameter. Parallel connection is possible with the sum of Y parameter. Now let us try to see the series interconnection. In this series interconnection, we will try to do the derivation for series connection of two-port network. So the connection is like this. Let us try to select, and this is a two-port network labeled as A, and this is a two-port network labeled as B. So here we have two terminals, this terminal 1, terminal 2, terminal 3 and terminal 4. Okay, so this is the terminals what we have for an two-port network. So this is a two-port network, this is a two-port network B. Now we need to interconnect it. So how to interconnect is, so here we are applying an voltage value of V1 and current into the network is I1. The current which flows into network A, I am going to label it as I1A, and I am joining the output of A is connected to B. The current entering into the B port is I1B. The current which flows I1A flows like this, and you can see here the current I1 flows and IA flows, and it flows like this, and it comes back and it form a closed path. This is I1A series connection. So coming to the output port side, so here we are exciting with a voltage of V2 and a current of I2 flows here, and we are going to interconnect A and B. The output of A is connected to input of B, and the current which flows into this A port is I2A, and the current I2A flows here. The current which flows into B port is I2B, and the same current. You can see here these are also connected in series connection. So now we need to find the relation. So voltage and current. At input port side, you try to apply the Kirchhoff's voltage law. At input port side, we are applying Kirchhoff's voltage law. So how to apply is, so current is leaving, what is the leaving polarity of the voltage is plus V1. Okay, so how to mark this voltage is, so the voltage at this point is positive and negative, and this voltage I am going to write it as V1A. The voltage at port B is nothing but plus minus, and we are writing it as I1B. So here the voltage I am going to write it as V2A. The voltage at port B I am writing it as V2B. So when you apply the KVL at input port, the current is leaving, the voltage I am going to write it as plus V1, and current is leaving, what is the leaving polarity? Minus V1A, and current is entering at positive terminal, leaving at negative terminal. The leaving terminal is minus V1B is equal to 0. And we can see here, I can write down this as V1 is equal to V1A plus V1B is our KVL equation. And similarly, apply Kirchhoff's voltage law at output port. Here apply the, so current is leaving, what is the leaving polarity we have here? Plus V2, and the voltage is leaving at negative, which is nothing but minus V2A, and it flows, and the voltage leaves, what is the leaving polarity? Minus V2B is equal to 0, and here you can write down V2 is equal to V2A plus V2B. So this is the second equation to what we are going to get. And when you check out here, the currents are same, so I can write down I1 current is equal to I1A is equal to I1B, which forms an closed path. I1 flows like this, and this current I1A flows like this, and the current will flow into the network as I1B, and it forms a closed path. Here also the current I2 is flowing like this, and the current flows into I2A, and once again it flows into I2B. So these are the KCL and KVL equations we have in our series interconnection. Now we need to use these equations and we have to form them. So before writing this, let's try to memorize it, how to write down the equations. So here I am writing the equations as in terms of Z parameters. In series connection, Z parameters plays a crucial role in characterizing the parameters of an series network, and here we are going to have V1, V2 are the input voltages is equal to, we have Z11, Z12, Z21 as well as Z22 multiplied with I1, I2 is the one matrix. Second matrix also V1, V2 is equal to Z11, Z12, Z21 as well as Z22 into I1, I2. So when you see these equations, you can understand better things. So here, this network I am going to call it as V1A, V2A, Z11A. I am just giving a suffix as A. So here we are going to give the suffix as B, and we are going to interconnect two port networks. So here what happens here is, so when you do like this, we have the equation, use this equation, V1 is equal to V1A plus V1B, okay, and here I can write down V1 is equal to, how to write down V1A? Multiplication of row into column. The row I can write down it as Z11A into I1A plus Z12A into I2A plus, how to write down V1B? V1B I can write down it as Z11B I1B plus Z12B into I2B is the equation. And already I know that I1A is equal to I2A is equal to, sorry, I1A is equal to I1B is equal to I1 only. Already you can see here I1A equal to I1B equal to I1. So just use this equation here and use the equation I2A is equal to I2B is equal to I2 here. Use the equation what we got here. Just substitute in this equation. Before V1 we are going to get it as, take I1 as a common term. When you take I1 as a common term, I1 into Z11A plus Z11B plus take I2 as a common term here. plus I2 into Z12A plus Z12B. So we have got one equation now. We have got one equation. So similarly, use this KVL here. So V2 is equal to V2A plus V2B. So therefore V2 is equal to V2A. How to write down V2A? V2A I can write down it as Z21A I1A plus Z22A as well as I2A. And how to write down V2B? V2B I can write down row multiplied with the column. So V2B I can write down it as Z21B I1B plus Z22B multiplied with I2B. And here I1A is equal to I1B equal to I1. Take I1 as an common term. Therefore then we are going to get Z21A plus Z21B is one term. And next term take I2 as a common term. When we take I2 as a common term, then we are going to get Z22A plus Z22B is the another term. So when you compare these two equations, then we are going to get the equation like this. So let's try to write down in matrix form. This is V1, V2 is equal to Z11A plus Z11B. This is Z12A plus Z12B. This is Z21A plus Z21B. This is Z22A plus Z22B multiplied with the currents of I1 and I2. So therefore, when you are performing the series connection of two-port parameter, we want to use the resultant answer is, this is sum of Z parameters of A and B. All the Z parameters get added with matrix wise. So this is why it is called sum of Z matrices. So this is called the sum of Z parameter matrix when you are performing the series connection of Z parameter. So if you feel the video is useful, please like the video, share with your friends, and if you have any doubts, let me know in comment section. And if you are watching the channel for the first time, subscribe to the channel in the name KB Kalsira. So this is a free channel for the betterment of student and faculty. If you feel the content is really useful, subscribe to the channel. Yours obediently, Ram.